Answer key, final review number 1. The definitions are in your book in chapters 5 and 6. At the end of each chapter, there are definitions, so it doesn't hurt to look those up and make sure you know those vocabulary words. Factoring. Completely factor the following expression. Number 1, x squared minus 8x plus 12. This is basic factoring because there is a 1 in front of the x squared. So what multiplies to be 12 and adds to be negative 8? This is going to be the numbers negative 2 and negative 6. Negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. So this is x minus 2 times x minus 8. Number 2, same idea. The 1 in front of the x squared tells me to use basic factoring. What multiplies be negative 200 and adds to be 10. Again, I need to find the factors of 200. If I don't recall how to find those or what they are, I can go to y equals. I can type in 200 divide by x. I can then go to my table. So my factors are 1 and 200, 2 and 100, 4 and 50, 5 and 40, 8 and 25, 10 and 20, which would get me 10 if I use subtraction. And then, that's my answer, 10 and 20. So what multiplies me negative 200 adds to be 10 is 20 and 10. I want it to be a positive 10 when I add, so the 10 needs to be negative, positive 20. So then I get x plus 20 times x minus 10. And that's my answer. Number 3, what multiplies to be negative 240 and adds to be negative 34. Again, there's a 1 in front of the x squared, so it's just basic factoring. I go back to my calculator. I hit y equals. I plug in 240, divide by x. I don't want the graph. I go to the table. Again, let's look at these answers. I have 1 and 240, 2 and 120, 3 and 80, 4 and 60. None of these so far will add up to 34. 5 and 48, maybe 42, but not 34. 6 and 40, if I subtract, will give me negative or give me 34. So I need 6 and 40. I want the 34 to be negative, so it needs to be a negative 40. So this is x plus 6, x minus 40. And again, that's my answer. I can always FOIL these to check that that answer is correct. And for these, they are. The negative goes right there. All right. Number 4. Number 4 is when we start looking at something different. My number in front of my x squared is a 5. So I need to use California method. A times C and adds to be B. So 5 times 3 is 15 and 16. What multiplies to be 15 and adds to be 16? I can look at my calculator. My factors are 1 and 15, 3 and 5. So 1 and 15 is what adds up to be 16. This is California method, so I have to do my fractions. 5x over, 5x over. What are they over? Well, it's over my factors, 1 and 15. 5x over 1 does not change, so that's the factor 5x plus 1. 5x over 15 reduces by 5. 5 goes into 5 once, leaving 1x. 5 goes into 15 3 times, so that's the factor 1x or x plus 3. If I FOIL that out, I would get 5x squared plus 16x plus 3. Let's look at number 5. Again, remember, now that I have a number in front, I do want to start asking the question, is there a greatest common factor? Is there a greatest common factor of 4, 20, and 25? The answer is no. Let's put that right there. So now I need to see if I can factor this. And remember, I can say what multiplies to be 100 and adds to be negative 20. But the next question that I want to ask before I go to the California method is this a perfect square? The answer is yes, 2x. Is this a perfect square? The answer is yes, 5. If I multiply 2x times 5, I get 10. If I double that, I get negative 20, or I get positive 20x. So if I put a minus in here, 2x times negative 5 is negative 20x. So this is my answer because it makes the pattern. This is a perfect square. This is a perfect square. If I square root them, multiply 2x and negative 5 and double it, I do get the middle term. So this is my final answer. Number 6, I'm going to do the same thing. I'm going to start by asking the same questions. Is there a greatest common factor of 4, 28, and 15? The answer is no. Is 4 a perfect square? The answer is yes. Is negative 15 a perfect square? The answer is no. So it's not a perfect square trinomial. I cannot do what I did on number 5. The last thing I can do is California method. 4 times negative 15 is negative 60 and 28. What multiplies to be negative 60 and adds to be 28. Again, you can do this in your head. You can pull up your calculator if you like. What multiplies to be 60 and adds to be 28. 1 and 60, 2 and 28. Excuse me, 2 and 30 can give me 28 if one of them is negative. So it's 2 and 30 that I'm looking for. So my numbers are 2 and 30. It needs to be a negative 2 because of that negative 15. I need a negative in there. Negative 2 and 30. So I'm going to go ahead and do my fraction. Start off with ax, 4x over 4x over what? Over my factors, negative 2 and 30. This reduces by 2, and I get 2x over negative 1. This one reduces by 2, and I get 2x over 15. So this is the factor 2x minus 1, and this is the factor of 2x plus 15. If I FOIL this out, I get 4x squared plus 30x minus 2x, which is 28x minus 15. There is my answer. Let's go on to number 7. Number 7, again, is there a greatest common factor of 6, negative 5, and negative 6? The answer is no. Okay, is 6 a perfect square? Is 6x squared a perfect square? The answer is no. So the last thing I can do is California method. 6 times 6 is negative 36. 6 times negative 6 is negative 36 and adds to be negative 5. Again, you can go to your calculator and see what multiplies to be 36. 1 and 36 will not give me negative 5. 2 and 18 will not. 3 and 12 will not. But 4 and 9 will. So I need a 4 and a 9. It needs to be a negative 9 to add up to be a negative 5. I need my fractions. I start off with ax. 6x over 6x over what? Over 4 and over a negative 9. Can I reduce 6x over 4? I can reduce by 2 and get 3x over 2. Can I reduce 6x and negative 9? I can reduce by 3 and get 2x over negative 3. So this is 3x plus 2 and 2x minus 3. There are my factors. All right. Last, number 8. Again, I want to start the same way. Is this a perfect square? The answer is yes. There are only 2 terms. If there are only 2 terms, the only thing I know to do for factoring is a difference of squares. So I have to see if these are perfect squares. Is 36x squared a perfect square? Yes. What? 6x. Is 25 a perfect square? Yes. What? 5. If, well, is it subtraction in the middle? Yes. So my answer is, forgive what I just did, my answer is 6x minus 5 6x plus 5. I didn't leave myself enough room. They're conjugates. They're the opposites. If I FOIL this out, 6x times 6x is 36x squared. My first 6x times, excuse me, that's my first. My outer 6x times 5 would be positive 30. My inner negative 5 times 6x would be negative 30. So they cancel. And my last negative 5 times 5 is negative 25. So that is my answer. 6x minus 5, 6x plus 5, a difference of 2 squares. Let's move on to this set of problems. Again, number 25, is there a perfect square that divides into 25 and 81? No, but there are 2 terms. So I want to see if this is a difference of 2 squares. Is this a perfect square, 25x squared? Yes. What? 5x. Is 81 a perfect square? Yes. What? 9. Is it subtraction in the middle? Yes. So 5x plus 9, 5x minus 9. Minus 9. That's my answer, my factors. Number 10, same questions. Is there a greatest common factor of 9, 60, and 100? The answer is no. Again, see if these are perfect squares. Is 9x squared a perfect square? Yes. What? 3x. Is 100 a perfect square? Yes. What? 10. If I multiply those, 3x times 10, I get 30x. If I double it, I do get 60. So this is my answer, a perfect square trinomial. Number 9, if I look at 9 again, the first question I ask is there a greatest common factor? Yes. 3 goes into 9 and 3 goes into 12, so I can pull out a 3. X goes into x squared and into x, so I can pull out an x. When I divide this by 3x, I get 3x. When I divide this by 3x, I get 4. 3x plus 4, there's nothing more I can do with that particular problem, so this is factored. Number 12, 3x squared minus 12. Again, is there a greatest common factor? From 3 and 12, yes, I can pull out a 3. If I divide this by 3, I get x squared. If I divide this by 3, I get minus 4. But wait, that x squared minus 4, that also is a difference of squares. So the 3 is in front. Is x squared a perfect square? Yes. What? 1x. Is 4 a perfect square? Yes. What? 2. Is it subtraction in the middle? Yes. So it's x plus 2, x minus 2. That's my answer. Next set of problems. Four x cubed plus 12x plus 8x. Okay, is there a greatest common factor of 4x cubed plus 12x squared plus 8x? The first thing you need to think about is I haven't talked about x cubes. So I have to be able to pull out at least an x. 4, 12, and x, I can pull out a 4. When I do so, 4x cubed divided by 4x is x squared. 12x squared divided by 4x is plus 3x. 8x divided by 4x is going to be plus 2. I factored out my greatest common factor. Look inside the parentheses. What multiplies to be 2 and adds to be 3x? The answer is 1 and 2. So 4x times x plus 1 times x plus 2. And there is my answer. Next one. Is there a greatest common factor of 1, 4, and 6? The answer is no. Is x squared a perfect square? Yes. Is negative 6 a perfect square? No. So this is not a perfect square trinomial. The last thing I have is basic factoring. What multiplies to be negative 6 and adds to be 4? Now at this point, you're going to sit there and you're going to wonder. The only things that multiply to be negative 6 are 1 and 6, 2 and 3. None of these are going to add up to be 4. So this is not factorable. Now, Is it solvable? Yes. If I had this equal to 0 and I needed to find a solution, I could use a quadratic formula. But for now, I'm not solving. All I'm doing is factoring, so this is not factorable. Number 15. Number 15. Again, is there a greatest common factor of negative 3x squared plus 42x minus 147? The answer is 3. But remember, I like my a to be the number 1. So I like it to be a positive number. So I'm going to factor out a negative 3. I factor out a negative 3, I get x squared. 42x divided by a negative 3 is going to be negative 14x. Negative 147, factor out a negative 3 is going to be positive 49. Now, are you going to have to be doing a little bit of calculator work if you can't do that in your head? Yes, you're allowed to use your calculator on the entire test. That's my greatest common factor. Now I have x squared minus 14x plus 49. Well, look at this. Is x squared a perfect square? Yes. What? X. Is 49 a perfect square? Yes. What? 7. If I multiply these, x times 7 is 7x. I double it, I get 14x. So if I make this negative, this, x minus 7 squared, is my final answer. So that is my final answer with a negative 3 in front. Number 16, I'm going to do the same thing. I see two terms, so I want to say a difference of squares, but there's an x cubed, so that also tells me there should be a greatest common factor. What number divides into 32x cubed and 72x? The answer is 8x. 32x divided by 8x is 4x. 72x divided by 8x is 9. Now this is a lie. This isn't 4x, this is 4x squared. I took out 1x, which leaves 2 x's on the inside. Now I need to go one step further. I have my 8x in front. Is 4x squared a perfect square? Since this is two terms, I want to see if this is a difference of two squares. 4x squared is a perfect square to x. Is 9 a perfect square? Yes. 3. Is it subtraction in the middle? Yes. So it's 2x minus 3, 2x plus 3. That is my answer. Keep working our way down. Solve by factoring. Solve the following equations by factoring. Show the equations in factored form and the solution. So I want to factor and then solve. So let's take these one step at a time. X squared plus 12x minus 45. Let's factor this. This is basic factoring because there's a 1 in front of the x squared. What multiplies will be negative 45 and adds to be positive 12. Well, again, you can use your calculator to come up with these factors. 45 divide by x, go to my table. 1 and 45 is not going to give me 12. 2 doesn't work. 3 and 15. 3 and 15 will give me a 12. So let's do 3 and 15. 3 and 15, since it's a positive 12, it needs to be a positive 15 or a negative 3, because negative 3 plus 15 is positive 12. So I'm going to factor these now. When I factor these, I'm going to get x minus 3 times x plus 15, and this is equal to 0. Well, at this point, I have two factors equal 0, so I can say x minus 3 is equal to 0, or x plus 15 is equal to 0. Let me do it this way. Or x plus 15 is equal to 0. I'm going to add 3 here. So x is equal to 3. Or subtract 15. x is equal to negative 15. Those are my two answers. And I need solutions. It said to solve. It said to solve by factoring. So let's go to number 2. Number 2, 5x squared plus 11x plus 2. 5x squared is not a perfect square, so I have to do California method. A times C, what multiplies to be 10, 5 times 2 is 10, and adds to be 11, that has to be 10 and 1. So my factors are 10 and 1, but I need my fractions, 5x over 10, 5x over 1. This reduces by 5 to x plus 2, x over 2, which becomes x plus 2. This is fully reduced, so this is 5x plus 1. This is equal to 0. Excuse me 1 second. So I again have to do x plus 2 is equal to 0, or 5x plus 1 is equal to 0. I subtract 2, I get x is equal to negative 2. I subtract 1, I get 5x is equal to negative 1. I divide by 5, x is equal to negative 1/5. These are my two answers. Now remember, this is a multiple choice test, so you need to look for both of those answers, not just one. Let's go to number 3. Again, the number in front, x squared is a perfect square. 4 is a perfect square. So that would be x and a 2. But 2 times x is 2x. Doubled is 4x. So this is not a perfect square trinomial. But it's good to try. So the only thing I'm left with is basic factoring. What multiplies to be negative 4 and adds to be positive 3. I get negative 1 and positive 4. So then my factors are x minus 1 and x plus 4. So that means x is going to equal 1, or x is going to, well, I went too fast. Let's slow that down. So that means x minus 1 is equal to 0, so x equals 1, or x plus 4 is equal to 0. Subtract 1 from both sides. X is equal to negative 4. Those two answers. All right, number 4. Again, this has two terms, a 9x squared and a 5x. The problem is it's addition, so this is not a perfect square. Excuse me, this is not a difference of squares, but I do have an x squared and an x squared. So I can pull out a greatest common factor of x, leaving 9x plus 5 is equal to 0. Now look what I have though. These are two factors. I have an x here and an x here. There's no x squares anywhere, so I can solve this. I can say x is equal to 0, or 9x plus 5 is equal to 0. Subtract 5. 9x is equal to negative 5. Divide by 9. X is equal to negative 5/9. There's one answer. There's the other. Let's keep on going. 3x squared plus 7x plus 4 equals 0. So I want to factor this. 3x squared is not a perfect square. So what I have to do is California method at this point. So the question is 3 times 4 is 12. What multiplies to be 12 and adds to be 5? Well, that's either 3 and 4, or, well, 1 and 2 and 6 won't give me 7. Let's step back and try this again. What multiplies to be 12 and adds to be 7? That's still not a 7. I'm still thinking of a number 5. I'm not sure why. What multiplies to be 12 and adds to be 7? That is the numbers 3 and 4. So this is California method, so it's 3x over 3, 3x over 4. This one reduces to x over 1, so this is x plus 1. This one does not reduce, so this is 3x plus 4, and this is equal to 0. So again, I have to say x minus 1, excuse me, x plus 1 is equal to 0. Subtract 1 from both sides, x equals negative 1. Or I have 3x plus 4 is equal to 0, so I subtract 4 from both sides. I get 3x is equal to negative 4. 3x equals negative 4. Divide both sides by 3, I get x is equal to negative 4 over 3, or negative 4 thirds. Those two are my answers. All right, continue. Too far. Number 6. 4x squared plus 44x plus 121. The fact that I have this 121 tells me that hopefully I can do this with a shortcut. So what are my shortcuts? Well, is 4x squared a perfect square? Yes. What? 2x. Is 121 a perfect square? Yes. What? 11. If I go 2x times 11, I get 22x. Double it, do I get 44x? Yes. So this is my factors. 2x plus 1 times, rephrase, 2x plus 11 times 2x plus 11. 2x plus 11 squared. That's equal to 0. But I have something squared, so I can square root both sides. I get 2x plus 11 is equal to, now normally we would plus or minus, but there's no such thing as plus or minus 0. It's just 0. So you subtract 11 from both sides, you get 2x is equal to negative 11. You divide both sides by 2, you get x equals negative 11 halves. Just one answer. And this is the only time you might end up with just one answer, because you took that square root of 0. And so you get just one answer. Number 7, again, 2 terms, and this goes back to being intelligent when it comes to taking these tests. I'm going to tell you to solve by factoring, and I'm going to show you solve by factoring. But you know what? There's an easier way of solving this without factoring. See if you can figure it out. If I was to solve this by factoring, is this a perfect square? Yes. What? 7x. Is this a perfect square? Yes. What? 3. If I is it subtraction in the middle? Yes. So it's 7x plus 3 times 7x minus 3. That's equal to 0. So I can then say that 7x plus 3 is equal to 0. Subtract 3. 7x is equal to negative 3. Divide by 7. X is equal to negative 3/7. Or I can say that 7x minus 3 is equal to 0. Add 3. 7x is equal to 3. Divide by 7. X is equal to 3/7. One answer, two answers. Positive or negative 3/7. Lastly, number 8. 6x squared minus 41 plus 3. Is 6x squared a perfect square? No. So this is not a perfect square trinomial. So the only way I have to do this is California method. So I'm going to still a little space over here, and I'm going to do this in black. And I'm going to say 6 times 30 is 180. Is there a greatest common factor of 6, 41, and 30? 3 will go into 6, 3 will go into 30, but 3 will not go into 41. So I have to use California method. 6 times 30 is 180, and adds up to be negative 41. I need my calculator for this. So I go to y equals, I do 180 divided by x. I go to my table. Negative 41. Well, 1 and 180, 2 and 90, 3 and 60, 4 and 45. 4 and 45. That could give me 41, but 5 and 36 can also give me 41. Which one is it? Well, if I tried 4 and 45, For those to multiply to be a positive 180, they'd both have to be negative, which would not give me negative 41. So negative 4 and negative 45 isn't going to be correct. What I actually need to use is 5 and 36, where they're both negative. They will add up to 41 and they will multiply to be positive 81. So those are my two factors. So now I need my fractions. 6x over negative 5, 6x over negative 36. 6x over 35 does not reduce. 6x over 36 becomes x over negative 6. So I get 6x minus 5 times x minus 6 is equal to 0. So I have my two factors. I can say 6x minus 5 is equal to 0. Add 5, 6x is equal to 5. Divide by 6, x is equal to 5/6. Or x minus 6 is equal to 0. Add 6, x is equal to 6. Those are my two answers. All right, keep going down. Solve quadratics by inverse operations. Solve the following quadratic equations using inverse operations. I have something squared, something squared, something squared. So what I want to do is square root and then solve for x. So let's try this on number 1. So the first thing I want to do, well, the quantity squared is by itself. So what I want to do here, first and foremost, is to square root to get rid of that square. I need to square root to get rid of that square. The square and the square root cancel, leaving x plus 4. The square root of 81 is 9, but it's also negative 9. All of these, except for special cases, should have two answers. So I have x plus 4 is equal to 9, or x plus 4 is equal to negative 9. That's a 4. Both I'm going to do the same thing. I'm going to subtract 4, so x is equal to 5. I'm going to subtract 4, so x is equal to negative 13. Two answers, or. Number 2, again, quantity squared on the left, square root both sides. Square and the square root cancel, leaving x minus 4. Square root of 100 is 10. The other square root of 100 is negative 10. So I have x minus 4 is equal to 10, or x minus 4 is equal to negative 10. Here I'm going to add 4. X is equal to 14. Again, I'm going to add 4. X is equal to negative 6, or. Two answers. Lastly, x minus 9 squared minus 121 is equal to 0. Add 121 to both sides to get the x minus 9 squared by itself. Now, I can square root both sides. The square and the square root cancel. I have x minus 9 is equal to 11. The other square root of 121 is also negative 11. Two problems. X minus 9 is equal to 11. Add 9. X is equal to 21. 20. X minus 9 is equal to negative 11. Add 9 to both sides. X is equal to negative 2. Two answers. Word or in the middle. That's the first page. Let's go. I hope that's the first page. Yes. Go to the second page. Solving quadratics using square roots. Just like on the last one when I got the quantity squared by itself. On this one, I want to get the x squared by itself. 5x squared equals 500. First thing I want to do is divide by 5. X squared is equal to 100. The x squared is by itself. So I'm going to square root both sides. X square and square root cancel. X is equal to 10. The other square root of 100 is negative 10. Two answers, positive 10 and negative 10. Number 2, I'm going to add 5 to both sides to try to get the x squared by itself. 2x squared is equal to 32. I still need to get rid of that 2. So x squared is equal to 16. Now, since the x squared is by itself, I can square root both sides. The square and the square root cancel. X is equal to 4. That's one square root of 16. The other one is negative 4. There's my two answers. Again, continue. Keep up the same thing. I'm going to add 54 to both sides to try to get that 6x squared by itself. Now to get rid of the 6, you're going to divide by 6. X squared is equal to 54 divided by 6 is 9. Again, square root both sides. The square and the square root cancel, leaving x is equal to 3. The other square root of 9 is negative 3. Two answers. Number 4. Subtract 3 from both sides. 1/2 x squared is equal to 5. Multiply both sides by 2. Now, this is 2 over 1, the reciprocal, which is the same as 2. The 2's cancel, the 1's cancel, leaving x squared is equal to 10. I need to get rid of the square, so I square root both sides. Square, square root cancel, leaving x. 1 square root of 10 is square root of 10. The other one is negative square root of 10. Those are my two answers. Lastly, worst comes to worst, you can always use the quadratic formula, solving quadratics by quadratic formula. You need to know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to know your quadratic formula. So I come to number 1. A is 1. B is negative 3. C is negative 4. Plug it into the quadratic formula. X is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times A times C all over 2, almost had it, 2 times A. Simplify. X is equal to negative 3 is 3 plus or minus the square root of negative 3 squared is 9. Negative 4 times 1 times negative 4 is 16. All over 2 times 1 is 2. 3 is equal to 3 plus or minus the square root of 25 over 2. That 2 should be up there. Sorry, this should be an x over here. So x is equal to 3 plus or minus 5 over 2. Well, x is equal to 3 plus 5 over 2 is 8 over 2, or 4. X is equal to 3 minus 5 over 2 is negative 2 over 2, which is negative 1. Two answers. All right. Number 2. Now, I could have tried to take out a greatest common factor. There isn't for number 1. There isn't for number 2. So I figure out what A, B, and C are, and I plug it in. X is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Continue. X is equal to negative 6 plus or minus the square root of 6 squared is 36. Negative 4 times negative 2 is positive 8 times 9 is positive 72 over negative 4. So x is equal to negative 6 plus or minus the square root of 108 over negative 4. Square root of 108. It's going to take a little doing in your calculator. I need to reduce the square root of 108 because my rule said I want an exact answer in radical form or whole numbers. Well, there is no nice square root of 108, so I'm going to leave it in radical form. So I have to decide what perfect square will divide into 108. So again, I'm going to go to, instead of 180 here, I need 108. I'm going to go to my table. What perfect squares do I have? Well, I have 4. I'm going to have 9. But right here I have 36. That's the largest perfect square I'm going to get. So I can say that this is negative 6 plus or minus the square root of 36 times the square root of, that was 36 times 3 over negative 4. So x is equal to negative 6 plus or minus the square root of 36 is 6 times the square root of 3 over negative 4. Now this I would like to reduce a little bit. So I'm going to come over here and say, well, this is equal to, I'm going to take a 2 out of this 6 and this 6. This is 2 times negative 3 plus or minus 3 square root 3, running out of space, over negative 4. Well, that 2 and that negative 4 are going to cancel, and I'm going to get x is equal to negative 3 plus or minus 3 square root 3 over negative 2. That's a good answer. I can also move this negative up into here and have this as x is equal to 3 plus or minus 3 square root 2, 3 square root 3 over 2. Either of these are the answers I'm looking for. Wow, that was a heavy problem. That was a hard problem. Might be something you might want to put off to the end. That's kind of something you need to choose and figure out. Let's go on. Give the answer. I can do decimals here. So I know that A is 1, B is 7, and C is negative 2. So I'm going to have x is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So x is equal to negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times 1 times a negative 2 is going to be plus 8 over 2. So x is equal to negative 7 plus or minus the square root of 57 over 2. Now, this said I can use calculator, so I'm going to bring up my handy-dandy calculator, and I'm going to come over here, and I'm going to go ahead and say I want negative 7 plus the square root of 57, close parentheses. I'm going to hit enter, and then I'm going to divide by 2, and I get 0.27. Or I did addition, now I need to do subtraction. So I'm going to do negative 7 minus the square root of 57. Enter. Divide by 2. And I get negative 7.27.